Hello, my name is Joel. I am a researcher here at WISE Lab for Innovations in Wireless Communications, Security and Sensing. Today, in this lecture, I would like to talk to you about our recently developed technology in the wireless communication area, which has been published as a conference paper in the 2020 International Conference on UK China Emerging Technologies, and can be found here. The paper has also been published in the RS Open Journal on Innovation Communication Technologies, and can be found as an open access paper. So this work is known as, the title of this particular technology is known as a novel small-scale non-orthogonal communication technique using auxiliary signal superposition with enhanced security for future wireless networks. As you may know, the Internet of Things, or otherwise known as Internet of Everything, is a system where everything is connected to everything. Literally, that's what it means. We're talking about smart homes, where we have smart appliances such as the refrigerators, the cookers, lights, and everything connected to each other and working together. We also talk about smart cars, smart devices installed in vehicles such as self-driving vehicles. We also talk about smart grids. Here we're talking about smart meters, and devices that monitor your power utilization and trying to and basically tries to optimize it. We're talking about smart cities. We're talking about other billions of devices such as phones, laptops, and so forth connected to the grid. We also talk about connected to the network. We also talk about smart infrastructure. So the Internet of Things, or Internet of Everything, is essentially everything connected to everything, or connected to the infrastructure. So the Internet of Things was made possible by the fifth generation network, and beyond. We talk about 6G as well, and this is because 5G and beyond technologies have increased data rate. They have reduced delays and also have enhanced cellular coverage in communication technologies. And some of the areas that will be impacted a lot when we have Internet of Things coming into its full development include autonomous driving, healthcare, entertainment, industrial appliances, smart cities. We also talk about smart energy grids. We talk about sports, remote surgery, and also we talk about drone delivery applications. The information being shared by all these devices is very sensitive information and very private information. Non-orthogonal multiple access is quite desired in the wireless communication area because of its high spectral efficiency, its low latency, improved coverage, as well as its massive connectivity. Essentially, its ability, the most desired part of it is its ability to provide services for more users with less resources. However, we have a very big security issue when it comes to conventional NOMA models. Here we take a look at the conventional downlink and NOMA model, and we can see that in the conventional downlink and non-orthogonal multiple access, we have two users being paired together, where the users being paired are users with different channel properties. One user with a good channel and another user with a bad channel. In this case, we have user 2 having a bad channel and is allocated more power, and user 1 have a good channel and being allocated less power. So looking at how user 1 obtains their information User 1 simply obtains the entire information and then takes the information of user 2 and then takes the whole information and subtracts it. Then it gets its information. And user 1 and user 2, on the other hand, receive the information and simply decodes it by taking user 1's information as noise. We can directly see here that there is a security problem for an internal eavesdropper, because user 1 always decodes the information of user 2. On the other hand, we can see that the noise of user 2 is enhanced because the signal of user 1 is considered as noise, in addition to the noise of the channel. This is bound to bring BER degradations, or bit error rate degradation, for user 2. Multi-user superposition transmission, or MUST, is a downlink NOMA model that was adopted by 3GPP, but then later on dropped in release 17 due to some performance degradations. Physical layer technology is another promising paradigm that provides a solution over conventional cryptographic methods. In cryptography, we have key sharing, where we have private and public key sharing. However, this technology is becoming very ineffective, especially due to the development of supercomputers, which are able to decode these keys in very few in a short time. However, in physical layer security, we don't use keys, or we don't use public or private keys. We simply use the channel characteristic of the user to essentially protect the information. So in this particular model, we use physical layer security and non-orthogonal multiple access to come up with a novel secure communication technique. And the novelties of this particular paradigm that we are proposing here is providing physical layer security design against internal eavesdroppers, providing physical layer security design against external eavesdroppers. We will also see that we're going to have a 2-round auxiliary signal based transmission for 2 users, and we will see why this is important. We also have low complexity, because the receiver simply receives information without doing any further complexities, and this is a very highly desired property in the current and future Internet of Things paradigms. We'll also see that we will have minimum computations. We have no power dependent communications for near or far users. Therefore, we do not need, we will see that the advantage of this is that we don't need to pair different users depending on their channel. So now let's look at the system model of this technology. This technology can be, first of all, it can be applied for many users, but for simplicity purposes and in order for readers to be able to easily understand, we are going to look at only a 2-user scenario.